Imagine building a house without a blueprint. Chaos, right? That's what happens when you build software without clear requirements. Requirements engineering is like creating that blueprint. It's about understanding what users need and translating those needs into detailed specifications. These specifications guide the entire software development process. Without this roadmap, developers are building in the dark. This leads to wasted time, costly rework, and ultimately, unhappy users. Requirements engineering ensures everyone is on the same page, working towards a common goal. Functional requirements describe what the software should do. They are the features and functions users directly interact with. Think of a banking app. A functional requirement could be users must be able to view their account balance. This clearly defines a specific action the software must perform. Other examples include transferring funds, paying bills, or depositing checks. These all describe the core functionalities of the app. Clearly defined functional requirements are crucial for developers to build the right features. Non-functional requirements focus on how the software performs, not just what it does. They relate to quality attributes like performance, security, and usability. For our banking app, a non-functional requirement might be the app must load in under 3 seconds. This doesn't define a specific feature, but it sets a performance standard. Other examples are, the app must be accessible on mobile devices, usability, or all transactions must be encrypted, security. Non-functional requirements are essential for ensuring the software is usable, reliable, and secure. Eliciting requirements is like detective work. It involves gathering information from stakeholders to understand their needs and expectations. There are various techniques for eliciting requirements, each with its strengths. Interviews allow for in-depth discussions with individual stakeholders. Ethnography involves observing users in their natural environment to understand their workflows and pain points. Stories and scenarios help stakeholders articulate their needs in a narrative format. Prototyping allows users to interact with a mock-up of the software and provide feedback. The key is to use a combination of techniques to gain a comprehensive understanding of the requirements. Section 5. Painting the picture specifying requirements. Once requirements are elicited, they need to be clearly documented and specified. This is where we translate user needs into a format developers can understand. Natural language, while simple, can be ambiguous. Structured natural language uses templates to add consistency. Graphical notations like use case diagrams provide a visual representation of user interactions. Formal specifications use mathematical languages for precise definitions. The chosen method depends on the project's complexity and the team's preference. The goal is to create unambiguous and testable specifications. Section 6. Getting it right, validating requirements. Imagine building a house and realizing the roof doesn't fit. Validating requirements prevents such costly mistakes in software development. Reviews involve stakeholders examining the documented requirements for completeness and accuracy. Prototyping allows users to interact with a working model and identify potential issues early on. Test case generation involves designing tests based on the requirements to ensure the software behaves as expected. Validation ensures that the right product is built, meeting the actual needs of the stakeholders. Section 7. Managing change, the inevitable evolution. Change is a constant in software development. User needs evolve, new technologies emerge, and market conditions shift. Requirements management involves handling these changes effectively throughout the project lifecycle. It includes a systematic process for documenting, analyzing, and approving changes. It also involves communicating these changes to all relevant stakeholders. Effective change management ensures the software remains relevant and adaptable to evolving circumstances. Section 8. Tools of the trade requirements engineering tools. Just like a carpenter needs tools, requirements engineers rely on software tools to manage the process efficiently. These tools help with various tasks like documenting requirements, creating diagrams, tracking changes, and collaborating with stakeholders. Examples include Jira, Confluence, and Microsoft Visio. Selecting the right tools depends on the project's specific needs and budget. These tools streamline the requirements engineering process, improving productivity and reducing errors. Section 9. The human touch communication is key. Requirements engineering is not just about technical processes and tools, it's also about effective communication. Requirements engineers act as facilitators, bridging the gap between stakeholders and developers. They need strong communication skills to elicit information, clarify ambiguities, and manage expectations. Regular communication, active listening, and clear documentation are crucial for successful requirements engineering. Section 10. Reaping the rewards, successful software development, mastering requirements. Engineering is not just a technical skill, it's a strategic advantage. It's the foundation for building successful software that meets user needs, stays within budget, and delivers business value. By investing time and effort up front in understanding and defining requirements, organizations can avoid costly mistakes down the line. Effective requirements engineering leads to higher customer satisfaction, reduced development costs, and ultimately, a greater return on investment.